All right, welcome back. This is part 4 of our series on building agentic AI from scratch without the frameworks. So far, we've covered getting set up with the API, we've tackled the whole memory problem, and we've talked about forcing structured JSON output. Today we get to the really fun stuff. We're going to unlock the true potential of our AI by giving it tools to actually interact with the real world. Let's dive in.
So I want to start with a question that seems a little bit weird. We've got this incredibly powerful AI, right? It can write poetry, it can explain quantum mechanics, but can it do something a second grader can do? Can it do simple math? You might be surprised by the answer.
And the answer is no, not really. And the reason for that actually gets to the absolute core of what a large language model is. They aren't calculators. They're just incredibly good at predicting the next word.
Yeah, this slide really lays out the huge difference. When you give a math problem to a program written in, say, Python, it follows a very precise, logical set of steps to get the one correct answer. But when you ask an LLM the same question, it's doing something completely different. It's predicting what the most likely next number is based on all the math problems it saw in its training data. It's a fantastic guess, but it's fundamentally a guess, not a calculation.
And you know, this problem goes way beyond just math. A standalone LLM is basically a brain in a jar. It's trapped in the past, with only the data it was trained on. It has no idea what the weather is like in San Francisco right now, and it definitely can't access your company's private database to check on a customer's order. It's this brilliant mind, but it's stuck in a locked room.
So how do we get it out of that room? How do we connect it to real-time information and all of our own custom logic? Well, the answer is this really elegant and powerful idea called tools. This is how we give our AIs some serious superpowers. And a tool is actually way simpler than it sounds. It's really just a function, a regular old function that you'd write in Python or any other language. The big difference is that you describe this function to the LLM so it knows it exists and what it's for. But the function itself, it lives and runs completely in your own code on your own system. So, what can you turn into a tool? Just about anything. You could write a simple calculator function to finally solve that math problem we talked about. You could write a function that hits a weather API to get live data. Or, and this is where it gets really powerful for businesses, you could write a function that connects to your internal database to figure out a customer-specific discount rate. Okay, so that's the what. But what about the how? The LLM can't just magically reach into your computer and start running your code, right? Instead, what happens is this little back and forth between your application and the LLM. I like to think of it as a kind of carefully choreographed dance. Let's break down the steps of this little dance. First, it starts with you. You send your user's prompt, but you also send a description of all the tools you have available. The LLM looks at all that, decides it needs help, and then it sends a message back saying, hey, please run this specific tool with these specific arguments. Then the ball is back in your court. Your code sees that request, runs your local function, and gets a result. Then you send that result back to the LLM in a new call. And finally, the LLM takes that new information and uses it to give the user a complete, helpful answer.
So, this is the most important thing to remember. The LLM is the brain of the operation. It's the delegator. It figures out what needs to happen and which tool is the right one for the job. But your application, your code, is the hands. It's the one that actually does the work and executes the function. The LLM never, ever runs your code. Okay, theory is great, but let's make this way more concrete. We're going to walk through a really practical example from an e-commerce site. We'll build a discount calculator to see exactly how you can hook up an LLM to your own business rules.
So imagine a customer types into your chatbot, hey, I'm a gold tier member, what's my discount if my order's $1,000? The base LLM has absolutely no clue. Your company's rules for gold, silver, and bronze members, that's your private data. The LLM needs help.
So how do we give it that help? Well, this is where our last explainer on JSON becomes super important. We have to use a very specific format, a JSON schema, to basically create an instruction manual for our tool that the LLM can understand perfectly. This schema has a few key parts. You've got the name of your function, pretty straightforward. You define the parameters or the arguments it needs to run, like the customer tier and the order total. But honestly, the most important part, the real magic, is the description. This is where you, in plain English, explain to the LLM what this tool is for and when it should think about using it. And you really have to nail this part. If your description is vague, something like just calculates things, the LLM is going to get confused. But a really good, clear description like calculates a customer's discount based on their specific tier and the total amount of their order,
Well, that gives it all the context it needs to make a smart choice. And once you have that clear description in place, you really get to see the intelligence of the model shine, because this isn't just some dumb keyword matching. The model makes really smart decisions about when to use your tools and, just as importantly, when not to.
So let's imagine we've given our LLM access to that handy calculate_discount tool. But then a user comes along and asks it completely unrelated question, like, what is the capital of France?
What does the LLM do? Does it get confused and try to calculate a discount? No. It doesn't break. It just answers directly, the capital of France is Paris.
And this is what is so incredibly powerful. Because we wrote a good description, the LLM understood that our discount calculator was completely useless for answering a geography question. It recognized that it already knew the answer and could just handle it on its own. And as the developer, you have total control over this behavior. You can set the tool choice parameter to auto and just let the LLM decide, which is what we just saw, but you could also set it to none to stop it from using any tools, or you can even force it to use one specific tool for a particular query. You're in the driver's seat.
Okay, that was a lot, I know. So let's just take a second and recap the absolute most important things you need to remember about how tools work.
So here are the big ones. First, tool calling is a two-way conversation. The LLM makes a request and your code does the work. Second, that JSON schema you write is the critical instruction manual for the model. Third, and I'm going to say it again because it's so important, the LLM is just the brain that delegates the task. It never runs your code. And finally, remember that the LLM is smart. It makes intelligent choices about whether a tool is even needed in the first place.
I mean, this technology just opens up a whole universe of possibilities, right? You can connect these powerful language brains to literally any data source or any action you can imagine. It really makes you think, if you could give an AI any custom tool in the world to solve any problem, what would be the very first thing you'd build?
Okay, so now we want to talk about step 4, which is tool calling. So we just finished talking about how we can extract JSON from the LLM, and that's because we want to enable what we're calling tool calling. So what is a tool? It's just a function that we can build on our machine that does something that the LLM probably can't do. So the trick is, how do we connect the LLM to our function? And of course, LLMs don't have the ability to come into your computer and run your operating system, or at least hopefully they don't have that ability. So how does it work? As we described, we set up a handoff, and the LLM tells us which function to call and with what arguments, but we run it and we send the results back. So let's examine how this works in code. So we start out as we have in the past. This is all the same. And now we need to define a function, whatever function we need. So that's what we're going to do here. And the name of this function is called calculate discount. And the purpose of this function is to calculate a discount based on an order total. So maybe the user is spending $1,000, but they are a gold tier customer, and so maybe they get a 15% discount. Or maybe they're spending $1,000 and they're a silver tier customer, and so they might get a 10% discount. Or maybe they're a bronze tier and they may get a 5% discount. So the purpose of this function is to calculate the discount in dollars. So for example, if it was $1,000 and they were a gold tier, then the discount would be $150. It would be 1,000 times 15%. That would be the discount. So that's the purpose of this function. And you can see that the parameters or the arguments are the customer tier and the order total. So it could be gold and $1,000, for example. And you can see that it returns the order total times the discount rate. So it could be 1,000 times 15%, which would return $150. Okay, so that's our tool, and we might have many tools, but right now we're starting small and we just have one tool. And one point is that the LLM has no way of knowing these rates. We have these rates available to us, but the LLM was built on data from a long time ago, or at least a while ago, and it doesn't know these rates, and it doesn't know about these categories, and so on. So this function lives on our machine, and the LLM can't see it, and hopefully it can't run it. So how does the LLM know that this function exists? we tell using a JSON schema. So here, this is the JSON schema that describes our function to the LLM. The LLM reads this to understand what the function does and what parameters it needs. We define something called tools, and it's a list. And in this list, it looks like there's a dictionary, and that goes down to here. So that's the end of the list. So each tool that we have will be such a dictionary. So we could have multiple tools. So we would have multiple dictionaries, each one with JSON that describes the tool. So this looks pretty much like part 3, but notice that type here is now function, not object. So we're describing a function here. And for example, here you can see name, and that's the name of the function. And that's the name of the function that we're going to want to call. And this part is important. It's a description of the function. And what does it say here? It says calculate the discount amount for a customer based on their tier and order total. So if you're not clear in the description, then you're expecting the LLM to just know what to do just from the name, which is probably not a good idea. So you should be as clear as possible with the description. And then we have the parameters, and we have the parameters for this function, our customer tier, and then we describe the properties of that. So it's of type string, we have a description of it, and we have this enum. So that comes from the English word enumerate. When we say, can you enumerate the reasons why you are against this policy, it means can you list the reasons. So enumerate means to list, and so here it means to list the possible values. So these are the only possible values that are allowed for customer tier. So we're only allowing bronze, silver, and gold, nothing else. Okay, and then we have another parameter called order total, and the type is number, and whereas the type before was string or customer tier. So order total is a number, and the description, the total order amount in dollars. These descriptions are important. And then down below we have required, and it says that both parameters are required. So the LLM must return both parameters to us. So the user might send something to the LLM. I'm a gold tier customer and I want to purchase this $550 purchase. What would be my discount? So the LLM has to parse that and then send back the parameters using this schema. Okay, so let's go down to here, and this should look familiar. Client chat completions create. This is familiar. Message. So the content here is user message, but that's from here. So what discount would a gold tier customer get on a $1,000 order? So that's the content, that's the prompt. And now here is a parameter that we haven't used before, and that is tools. But up here we've already defined tools, and in this case there's only one dictionary in it, but we could have multiple tools. We could have many dictionaries in it, one for each tool that we're alerting the LLM to the existence of. So tools is set equal to the list of tools that we've created, and there's another parameter called tool choice, and that's set to auto, and this allows the LLM to decide whether to use a tool or just answer. So we only have one tool in this example. That's the calculate discount tool. So if we asked the LLM, what's the capital of France, it would hopefully know not to use this tool, the discount calculator, to try and answer the question about the capital of France. But if we set it tool choice equal to auto, then it has the option of using the tool or not using the tool. So other options are none, so never use tools, or type function like this, name calculator, calculate discount, force this tool. So that would force the tool to be used. So when we run this, we store the response in response, and then we can do response.choices.message, and the message has a tool calls attribute. If the LLM wants to call the tool, this will be a list of tool call objects. On the other hand, if the LLM just wants to respond with text, this tool calls attribute will be none or empty. So we can try this if message tool call. So if this will run if there is a tool call, and then we can print out the LLM has decided to call a tool, and we can get there might have been multiple tools that have been called, but we can get the first one by doing this and calling that tool call. And then we can get the tool call ID, the function that ran or the function name, and the function arguments. Here for this example, what discount would a gold tier customer get for a $1,000 order? The LLM decided to call a tool, so that printed out. And then we can get the tool call ID, we can get the function name, we can get the function arguments. The function arguments from this prompt are customer tier, gold, and customer order 1000. So we just saw what tool call.function.arguments looked like, and we can see it here. And we can see that it is a dictionary. Key value pairs, customer tier, gold, order total 1000. So what can we do with this? We need to calculate the discount. So what do we need to do? We need to put in gold as the parameter for customer tier and 1000 as the parameter for order total. So we take that dictionary, and actually I misspoke. It's not a dictionary, it's JSON. It looked like a dictionary because we did this to it, but it's JSON, but this function turns that JSON into a dictionary. So arguments is that dictionary that I just showed you. And since it's a dictionary, we can retrieve the customer tier by doing arguments, square brackets, customer tier like this. And we can also retrieve the order total by doing this. But there's an easier way to do, and that's just to put these two asterisks there and put the arguments. And these will unpack the parameter argument pairs for us. So we're putting that into our calculate discount function, and so we'll get a result. Hopefully it'll be $150. Okay, so let's take a look at step 5. So this is where we actually fill in the arguments and get the result. So here, let's check to see that the result is actually correct. So this is after we printed these, and now we're going to print, we executed the function and got the result. So let's see what the result is. So this is the previous prints, and here is we executed the result and got $150. So that's good. Okay, so we got the result, and that could be good enough. We could just be happy with $150, but typically we will send the result back to the LLM, and the LLM will either formulate the answer a little bit more nicely, so it might say your discount is $150, or it may use that $150 in a second calculation. So anyway, in both cases, we want to send the tool result back to the LLM. So we want to send the tool result back to the LLM. So we do this by making another API call, and with the full conversation history, we have to see what exactly the conversation history is going to look like now. So the conversation history is going to have the original user message. So that's something like I'm in the gold tier and my order is $1,000. So what is my discount? So that will be the original user message, and that will be part of the conversation history. So this will be the assistant message, which includes the tool call. So this is the reply from the assistant after we send our original user message. And then we'll get the tool result. We just saw that we got the result, and we're going to send it back. So we need all three of these in the message or in the conversation history. Okay, so let's remember we already did this client chat completions create when we sent our original user message. Now that has completed, that's over, and we have to send a new message. And the LLM has no awareness of the previous call or the previous message. And that's why we need to include the original message here And we actually have to include what the assistant sent back to us, because again, this is a completely new and independent call to the LLM. And then after that, we will take the result that we got, which was $150, and send that back as well. So we have to include all three of these in the conversation history. In other words, in messages. So that's what we're doing here. The first part is message 1. So the role is user, and it's the user message that we had originally. That was already defined in our prior code. Now message 2, and we have to tell the LLM that this actually came from the assistant, actually came from them, but an independent them, so to speak. But anyway, the role was assistant. And here the content is none, but we have another key, which is tool calls. So it wasn't really sending anything back to us. It was just asking us to run our. Now, remember earlier, we already defined tool call ID. Let's just check that. So I should say we already defined tool call, because message tool calls 0 was the first, probably, or maybe the only tool call that we asked for. So that would be our discount calculation. So that is tool call, and tool call is of type message, and it has, as we described earlier, it has an ID field, it has a name field, and it has a function.arguments field. So we can refer to all of them now. So that's what we're doing here. We're telling it the tool call ID, so it knows specifically what and when the tool was called. And then the name is toolcall.function.name. And then the arguments is toolcall.function.arguments. So that is message 2. And then message 3, again, another message in our conversation history, which is actually messages here. And now we have role of tool, and the tool call ID, we have that already. And we also send back our result as a string, and that is the content. And so that is the message history that we have to send back. It's a little bit complicated, but we need all three messages because, as we said, it's an independent call to the LLM. And we also send back our list of tools just in case the LLM still wants to call another tool. And then again, let's go back and see what we called this connection to the LLM. We called it the second response. So we can get the second response content, and we'll call that the final message. And if we want to see what the LLM prints out, so just leave it as $150, or does it make it more pretty or a nicer response? Let's see what it does. So let's look for in the printout, after receiving the tool result, the LLM responded. And if you scroll down, this is what we saw before. Now we see after receiving the tool result, the LLM responded. So it didn't just give us $150. It said a gold tier customer would get this on a $1,000 order. So we can say it prettified the answer. Okay, so that is how we run an example where the LLM decides to call the tool. Now, very quickly, we'll go through a few more examples here. So we'll go through an example where the LLM decides not to call the tool or not to call any of our tools. And our example will be if we ask what is the capital of France, then it won't call our discount calculator tool, hopefully. And then we could also consider the example where there are multiple tools available and it has to decide which one. So we might give it an additional tool, like something that can access some weather API, and then it has to decide, should it not call any tool? Should it call the discount calculator tool? Should it call the weather API tool? So it has to decide, so we can examine that as well. So let's examine these last two quickly. Okay, this is example 2. The LLM chooses not to call the tool. And so we're going to do client chat completions create. We're going to make a connection. We're going to call this response 2. And the user message is just going to be, what is the capital of France? So that doesn't require our tool. We are going to provide our tool, and we set tool choice to auto. So that means the LLM can choose to use the tool, but it can also not use the tool. Then we take response and get the message and call it message to. And then we're going to check with a print statement if message to dot tool call. So if it does actually call a tool, this will not be empty. So this will print. So we'll check to see if this actually prints. And that would be surprising because we don't expect it to call a tool here. So we'll print the LLM called a tool unexpected. And otherwise, what we actually expect is that the LLM responded without calling a tool. Then we'll get the response from the LLM regarding the capital of France. And we can see here in the printout that when we ask what is the capital of France, it doesn't use a tool, so the LLM responded without calling a tool, and it just gives us what we would expect, which is that the capital of France is Paris. So no tool used. Okay, so here we have example 3. This is the case with multiple tools. So we only have one tool so far, so we're going to define our second tool, which is get weather. Now, we're not actually going to make it go and contact an API because that's a little bit more complicated. So we're just going to make up fake data. But, of course, you wouldn't want to make up fake data for what the weather is. You would want it to actually call an API. But for this example, we're just going to make up some fake data. So we're going to say that the weather in New York is this, and the weather in London is this, and the weather in Tokyo is this. So that will be our weather data, and we're going to access that instead of actually making an API call. And just to explain this code a little bit, weather data is a dictionary, so we can use weatherdata.get, and we can get the weather based on the user's specified location. And if none of them are there, if they ask for something like Chicago, then this is the value it will default to. So that's the get function. We saw that before. Now, just like before, we have to define the tool schema. And here we're going to have 2 tools. And just like before, each one is going to be a dictionary or JSON. And so the first one is defined here, and that's for the calculate discount. And that goes down to here. And then we have another one here, and it starts there and goes down to here, and then the whole list ends. So again, this is a lot of work, and we're going to see that this work plus a lot of other work can be done for us, so we don't have to write out these schemas when we use LangChain. And also all the passing of messages back and forth, LangChain will handle for us. Okay, so we've defined the 2 tools. We put them in the JSON schema and called that list multiple tools. And we'll want to provide that to the tools down here, the tools parameter. We want to provide multiple tools to the tools parameter. And then the user asks a question, and we send that. And of course, tool choice is set to auto, so it can use any of the tools or none of them. So tool choice is auto. And now this is all set to response 3. So we can extract information from response 3, and we can, in fact, extract the message. Now, whereas before we were expected to send back another message back to the LLM after we got the response from the LLM, and after we actually used the tool call in our function or in one of our functions, we aren't going to go through that full set of steps here. We're just going to put it into the function and see what the function gives us. We're not going to bother to send it back, which was pretty elaborate. And we're just not going to go through that again. We don't need to see it again. But we do want to see if a tool call was made and which tool was specified to be called. But we do want to see which tool the LLM recommends that we use, and we want to check the parameters that it's sending, and then we'll actually put those parameters into the tool and get the result. We just won't send another set of messages back to the LLM. We're not going to do that part. So the first thing we're going to do is check to see whether the LLM is asking us to make a tool call. So we do message 3 because we're working from message 3, and we check its tool calls. And this could be empty, but it might have a tool call on the other hand. And if it's not empty, then we'll extract the tool call, and it could give us actually more than one tool call, and we just want the first one, at least at first. So we're getting the first tool call, and we're calling it tool calls 3, and then we're getting that function name, and we're printing that out. And then we're also going to get the arguments, which comes from tool calls 3 function arguments. And we're going to do JSON loads that to get the arguments as a dictionary, and then we can examine that as well with a print statement. And now we can get the result by determining which was the function that was called. If it was the getWeather function, then we want to put the arguments into getWeather. So we do this, arguments 3 with the double asterisk. And if it was calculate discount, then we want to put arguments 3 with the double asterisk into calculate discount and pass that to result 3. And then we can print out result 3 and see what actually happened. Do we get an information about the weather, or do we get information about the discount? But scrolling up to the top here, we saw that user message was what is the weather like in Tokyo. So we hopefully won't use the discount function. Hopefully the LLM won't have asked us to use the discount function. So checking to see what happened in example 3, multiple tools are available. Our question was, what's the weather like in Tokyo? Is it going to use the discount function? Is it going to use the weather function, or is it going to use none? And so the LLM chose to use the getWeather function. And then we wanted to see what the arguments were, and it was location is Tokyo, and then the result was cloudy and 20 degrees. Okay, so now we've seen, in addition to the original tool calling exercise, we also saw an example where even though there was a tool available, the LLM didn't use it when the prompt was, what is the capital of France? And then we saw the case where there's multiple tools, and the LLM chose to use one but not the other, and it chose to use the weather API tool based on what the weather was in Tokyo. Okay, so next we're going to go to LangChain, and we're going to see how much easier LangChain makes all of this. For example, we had this getWeather function, which was our second tool, and we have to define that. But then we also had to write out all this JSON for it. So one of the advantages of LangChain is that you don't have to do this. Of course, you have to write the definition of the function. But once you've written the definition of the function, all you have to do is this. And this will do a lot of work for you. So this is called a decorator. And you just put the tools decorator there. And now this will generate the JSON for you. And there are many reasons to use LangChain. This is just one of them. So LangChain's tool decorator and bind tools do all of this for you. They generate the tool schema from the function signature, so you don't have to write out the JSON. Handle the tool call parsing, manages the back and forth conversation. But underneath, it's doing exactly the same that we did here. So it's good to know what's going on underneath, but now that you won't actually have to do this when you use LangChain or various other frameworks, agentic frameworks.